All right, in this video, I'm going to go over evaluating some complex numbers, getting them down to their standard form, and plotting them on a complex coordinate plane, which is actually really simple. Well, first of all, let's look at this. Square root of -9. Well, we can take the square root of 9, right? We just can't take the square root of -1. There's no number that multiplies by itself to get a negative number ever. It just never happens. But we can still do this, right? And we can use the symbol or the letter that we use to represent the square root of -1, which is I. And yes, it has that little fancy tail on it. So square root of -9, 3i, same thing, right? Now, standard form, there usually is some other extra number here, plus 3i. But we won't really come across any examples of that where you evaluate them like that until later on when we use the quadratic formula of that thing. Anyway, let's do this one too, just for practice. So 24, any square roots in there? Factor into 24. We know the square root of -1 is going to be separate. But what multiplies together to get 24? Well, 4 does. That's a perfect square. Square root of 4 times the square root of 6. Yes. Okay. So we have this square root of 4, which is just 2, right? We have our I, and we have what's left, square root of 6. Yes, I know 2 times 3 is 6, but 2 or 3 is not a perfect square. Neither of those are. So we just leave it as square root of 6. Some people might put 2 square root 6i, but I find that confusing because people might think that the I is underneath the radical symbol. So try to put the I out front like this. And they also have the 0 plus out there just to represent standard form, but I don't think you really need that. I mean, you all know it's plus 0. All right, this is the second part of the video. I'm just going to quickly go over how we plot these complex numbers on a coordinate plane. Now, we use a complex coordinate plane. What does that mean? Well, we have the normal x-axis, which goes off in both directions. This would be the negative x direction. But the y-axis is a little different. It's going to be imaginary. What does that do? Well, that makes it really simple for us. If we want to graph 3 minus 5i, 3 minus 5i, we just say, okay, well, this 3 is our x coordinate, and -5 is our y coordinate, or -5i. I mean, it doesn't matter. So you just treat it like it's xy. 1, 2, 3. Minus 5 is 1, 2, 3, 4, 5, all the way down here. And there we go. That's our first spot. 3, -5i. Put the I there if you want. And the other one, same thing. That would just be -2, 3i. 1, 2, 1, 2, 3. Well, that wasn't so bad, was it?